So we already have a couple of interesting discussion points and questions. I see Roman on here, so I'm gonna take the opportunity to kind of bring this up because I know Anna's thought about this a little bit, and I saw the infrared mentioned in a couple of talks. I noticed that like Rahul got JWST time, so there's obviously an interesting motivation to get infrared observations. So I'm curious to the speakers, what is it that Roman can provide, if not from the existing core community surveys or general astrophysics surveys, what type of observations might be designed to shed more light on relativistic transients? So I'll point that question to our speakers first.
Right, so the nominal 5-day cadence is not naturally well suited to the sorts of phenomena that I think we've been talking about. Obviously, it is also very sensitive. So as you get to higher redshift, some of these events do become a little bit slower. Perhaps I'm just spitballing a little bit. Perhaps you could try to look for some of these sort of day timescale transients, like these LF bots, out to much higher redshifts, which we haven't really been able to do with current surveys. But I suspect that a dedicated sort of proposed survey would be maybe more impactful for this area than that nominal 5-day cadence survey, just because I think it's a little bit slow for this kind of science. And Rahul's JWST, the JWST program Rahul was talking about is more for getting multi-band observations to do a single snapshot of the SED. So it's not really a survey kind of observation.
Okay, any other thoughts from our speakers or from the audience? All right, so we can, okay.
Well, just because we have some time to kill. Uh-huh. So I agree. This comes up a lot. Roman is not well suited for fast transient science. The way that I don't have a good answer for this, but the way that I would encourage everyone out there to be thinking, especially with all the bright and creative minds, is you have to realize we're going to be covering only about 20 square degrees, right, in the time domain survey. So compared to some of the the fraction of the sky that you need for like these LF bots, that's not, you don't really want to be thinking from the time domain survey point of view. But from the wide area survey, you're going to be covering 5,000 square degrees in multiple filters over 5 years. And just some fraction of events are going to sync up with a fast transient that is well covered with Rubin and potentially other telescopes, right? And so the way I would think about it is, what sort of infrastructure do you want to, and search capability do you want to build into the Roman, alert stream, so that you're able to identify these events and utilize, even if it is just one epoch, a very well sampled SED out into the infrared with great resolution. And what will you be able to do with that for some fraction of events, whatever that fraction is? If that fraction ends up being just a few percent over 5,000 square degrees, but that gets you a sample of like one or 200 objects, now suddenly you're talking about a new phase space of analysis. So anyway, I'm just trying to redirect the conversation from your typical thinking of what high cadence fast transient follow-up is, and try to utilize what these single snapshots might actually be able to get you, especially if they pile up over a very large fraction of the sky.
So to summarize that point, it was, how can we just utilize maybe single snapshots or coverage from Roman in combination with other existing surveys? But yeah. Any thoughts on that comment from Ori? Okay.
Yeah, I think building off of Ori's point, I think one important development from Roman would be an all sky reference or a wide field reference image in the near infrared that would enable rapid analysis of near infrared observations from ground-based telescopes, enabling faster science instead of having to wait for getting reference images from the ground or from other surveys.
Cool, thanks. All right, any other thoughts on this Roman-related discussion? All right, let's open it up to these other points here. So these are quite interesting questions about target prioritization. Yeah, I'm curious if there's any thoughts or feedback, or if any of the speakers wanted to provide more information or detail on that point. Or any of the points listed on here for facility coordination. Okay, Anna?
Yeah, I guess I could address how and when we can trust classifications. So for the relativistic explosions we've been talking about in the session, I think what we've learned is that the first limitation is our information about the host galaxy. So one of the main degeneracy is the right word, but sometimes you don't know whether you're seeing a fast transient at low redshift, which could be something like a shock cooling peak of a 2B, or if you're seeing an LF-bot at high redshift. And so a big limitation has been the reliability of PhotoZs in galaxy catalogs. And then ultimately for these relativistic transients to be convinced about what you're seeing, you need not just the initial discovery survey, but you need multi-wavelength data. So we have been relying pretty heavily on radio detections, but there can be some latency to being able to get those. So yeah, I guess I would just say you can't really trust what you're seeing until you have detections in multiple parts of the electromagnetic spectrum.
Cool, yeah, that's a good point to emphasize. Thanks, Anna. Okay, it looks like Dave has some thoughts.
Well, I really enjoyed the test talk and following up with LSST. I mean, ZTF, even LSST very closely. I think we could be doing more of that, with Ultrasat coming up, that 200 square degrees where they're imaging constantly. We should be tiling that region all the time and finding very young supernova and things like that with that. So I really like that idea. We should keep up with that kind of thing.
Cool.
I mean, I think to add on to that point, right? If we're talking about facility level coordination, then I think something that's important is like for these sort of predetermined surveys like TESS and even Ultrasat where the fields, like in TESS, at least the fields are set like a year in advance. I'm not sure about the timing of Ultrasat, but it would be important to maybe get like simultaneous observations of those different survey fields so that we can be like, okay, if we see something in Ultrasat, did we see something in TESS, and that way we can sort of like cross-reference the two surveys and get sort of that early multi-wavelength data that we so desperately crave for these relativistic transients.
I think we have maybe a TESS comment from Rebecca here.
Yeah, so what would you like in TESS extended missions? What would you like the next things to be?
That is a great question. I think, at least I know Cycle 9 is like going back to the north and revisiting the north. And so I think maybe I don't think any of Cycle 9 will overlap with Ultrasat as far as I'm aware. So maybe like when thinking about Cycle 10, maybe thinking about like, how the fields can be like maximized to like sort of overlap with Ultrasat. And I know that like Chinan's working as like the TESS Ultrasat fellow. And so like he might also be a good person to like chat with as well about sort of how we can combine TESS and Ultrasat for these early time observations that we really, really want.
All right, any other thoughts or comments? I saw maybe a hand coming from Dave, maybe not. Okay. But yeah.
I thought you had said TESS couldn't measure your LF-bots.
Well, they're not. Oh, sorry, yes. We get like a nearby LF bot, like, within a redshift of like 0.1 maybe or less, then TESS should be able to detect it based on our calculations. And I'm happy to share more information later.
All right, maybe final comment from Jacob back there.
I could say something about Ultrasat scheduling already now. And that will to a large degree be set by the constraints from, I mean, as Leo showed, the pointing angles and avoiding dust and a huge field of view. And then just based on geometry of the wide Ultrasat survey, that will be set pretty far in advance just due to the geometry. So I think that should be easy to schedule from and easy to plan.
All right. Oh, super quick.
Just to add to what Jakob was saying, I think the high cadence fields are set, right? So those are already out there. So you could start characterizing those fields now. We've been trying to do that with ZTF.
All right. On that note, let's wrap up the first session of the day.